welcome to this AskTom session on JSON, and it's been a while. We've canceled a couple of those, so I'm very excited that we have a new one, and this one is actually pretty interesting because I'm going to tell you what's new for JSON in 21C. If you have any questions, just put them in the chat or Q&A, and we will have time at the end to go over the questions. And Stephen, if there is a question that you think needs to be answered right away, then just feel free to interrupt me.
I'll do that.
Good. Perfect. So the first thing I did this morning was wasn't really the first thing, but sometimes around this morning, I looked into my cloud account, the always free that I used with my private email. So if you don't have a cloud account yet, please do so. It doesn't cost any money, and you always get a database, which is always free. And I saw that I could choose the 21C database version here. That's exciting. That's Oracle's latest release. I don't even know if it's officially announced yet or not, but it seems to be there. And then I also looked at the documentation here at this window here, and the starting page does not list the documentation yet. But if you Google for it, Oracle 21C JSON Developer Guide, you see that the documentation is up. Same with a SQL reference. So Oracle apparently already has published it, and Google has indexed it, so you can find it. And with that, I want to just go briefly over the release version. So JSON, as you may know, started in 12.102. It's not even on the slide here that I stole from a Jenny presentation. And 19C, which has pretty good support for JSON, that's going to be everything. It's here is like subject to change, so don't cite me if something gets modified. But 19C is a long-term release, meaning it gets extended support. And then there used to be like a 20C, and I believe we did a AskTom session where I showed how to get a 20C in the cloud. It was called a preview release. It was never available really for production. But I've shown that JSON Type and JSON Transform came in 20C. And since 20C never really made it to customers, or maybe some people tried it out, it is officially first occurring in 21C. So that's why I'm also presenting JSON Type here. Some of the capabilities that I present today have also been backported into 19C patch sets. So even though they're kind of new in 20 or 21, people will slowly get them if they upgrade or if they install these bundle patches on 19C. And for some of these things, I may not tell you, is it 19.7 or 19.9? I could look it up if you're really interested in it, but I have not prepared like a matrix watch. So I have a 21C Docker here. That's kind of a privilege working as a developer for Oracle, that I can get a Docker image from our daily build. So I've used this here, and I'm doing a connection to that Docker instance. Theoretically, I have not tested it. The same test case should work with if I would connect to the cloud database here. Good. So first of all, one feature I want to show you is JSON Type. That is just to verify, I got a 21C database here, and JSON Type is a new SQL data type similar to varchar or date. It's a dedicated data type. And under a cover, it uses a binary representation of JSON. We're no longer storing the JSON data as a text. It does not no longer needs to be parsed, but instead it's in a post-parse binary representation. And let's take a look at it. So for this, I want to compare it with a text storage. So I create a table called text here, test text, where I store my JSON text in a blob. And to make sure that the data is actually valid JSON, I add this check constraint. So this is the mechanism that exists since 12.102, a check constraint to make sure that it's JSON. And in the second example, I call it test JSON, this table. All I have to tell is that my test column is of data type JSON. So now if I describe it, I should see here, yes, this is really a JSON. So now I want to, in order to compare some things, I need to insert some test data. And instead of loading some of the file system, I actually want to generate the JSON from some existing object. So this is a pretty empty database. So I'm using these dictionary tables, obj $, which is the table that stores all the database objects. So even if you have an empty database, there are already 74,000 something objects in there. And what I do is I convert them into JSON. So this is a JSON constructor. And here we see the first thing. Well, we don't see what the JSON is. It just says this is a blob. And two things to be said for this. First, this is the latest version of SQL Developer here, but it has no support for JSON type yet. So it shows that under the cover, this looks like a blob. So this is why it prints blob here. So what we do in order to print it, we convert it to a JSON text, and we use the JSON serialize function here. So again, I'm generating this JSON of every row. So you see that these columns, spare 6 or link name, they are converted to field names in the object. So I don't have to list them here. Instead of just use the wildcard star and converts them all. You see there's a bunch of null values, but there are also some values which are populated. So obviously a null value in the table becomes a JSON null here. So these objects are pretty small. So on average, they're just 600 something bytes. So we see customer data typically be larger, maybe on average 10 times this size. So what we do, instead of having these 74,000 separate JSON objects, we just convert them into a big array. So I'm using this JSON array egg function, saying returning clob, and I get basically one result back. And I use this. Now I run this statement again. This was just to show you that this is the big array. And now I use the same stuff. Takes a while to insert it into my test JSON table. Maybe let's do a commit here, doesn't hurt. Okay, so now what I can do, I should have now, let's just do select count from test JSON, and we should be seeing like exactly one row, and it is relatively big. So now it's 20 megabyte big. That is far bigger than we see the average data. But this is just to show, to do some comparisons on the size of this binary format. So what I do now, so this is my test JSON table. Now I populate my text table. And what I do is I convert this large JSON array, which is 20 megabyte large. I convert that into textual representation. I insert that into my text table, test text. So now what I can do is I can look at the size of my text. And those are 44 or almost 45 megabytes. So the same data as text takes 45 megabyte versus 20 megabyte for the binary format. So in this example, which is a bit atypical because the data is very large, we save about 50% on the storage. And the question is, why is that the case? And the reason it's the case is if we look again at the data that's being generated, and this will be inserted into an array, then you see a lot of repeating key names. So you see spare 6 for every object or link name for every object. And we do replace these field names with IDs. So the way this binary data type works is it basically separates the JSON into three sections or 3 parts. One is a dictionary of the field names and maps them to an ID. The second part is the structure, like what is the parent-child relationship of these keys or of these values, and the last part are the actual values. And by this, and the structure basically has offsets or pointers to the values, which allow us to jump straight at the value instead of streaming, where I have to parse through it and do some sort of streaming processing. So this is the main explanation why we see about 50% of saving, is that these repeating field names are compressed. Good.
Ada, I have a question for you.
Yeah.
From Judith, it looks like essentially the JSON open squiggle star close squiggle behaves the same as JSON object. Is that true?
Yeah, yes, that's the short version of JSON object.
And is that new to 21C, that syntax?
No, that is, I think, new in 19. Good question, excellent question. That is the same as JSON object star. Yes, that's the short version. It's basically short for this. Yes, that should already be the case for 19.
Great, thanks.
Yep. Good. And if it's not part of 19, of the first release of 19, it definitely was backported. I'm pretty sure about this. Good, good, good. So now we've seen that for this particular use case where we have pretty large JSONs, we get good compression. Let's take a look at the performance. So again, we do, oh, this is just JSON serialized. We'd have to say returning club here. So this is the data. It does not fit into the default, and unfortunately the null on error handler just returns it as a null. So this is our value here, and you see that, do we see this here? There is a value called type somewhere, and we want to find out the maximum. So it's just ordered differently. Just imagine there is like a type, and we want to find the maximum of it. So first is the JSON. Now, obviously for the timing, it's, oops, why does it say null? Oh, it's both null, interesting. Well, it's null. Let's maybe take a different one. Let's hold on, that shouldn't be the case here. Just give me a second to think here. What went wrong? Oh, I know what went wrong. Basically, I reordered something. Yeah, okay, we do a little live change here. Oh, no, sorry, I scrolled too much. See, when I scrolled up and down, I skipped the part. I think it's all good. Good. Let's go back to what I just earlier said here. On these large documents, we get like a large compression of about 50. Let's, instead of this single large document, let's say I use these individual 70,000 documents. So what I do now is I don't use the JSON array. Instead, I insert every row as a JSON into my test JSON table. And I do the same with my test text. And then I believe this all makes sense. Exactly. So let's now look at the data. Now we're looking here. So now you see I don't have like one large array. Instead, I have many separate objects. So now let's look at the size savings here. So now we do have test text gives us 44 megabytes. So it's basically the sum of the length of every column. And this was pretty much the same. We got like 44, 45 that we got with the array. It's just, instead of it being in an array, it's just individual records. So for a text, that does make a big difference. But now let's look at the JSON data type. And here, actually, we don't get any compression. It's actually a little bit larger. And this is because there are no repeating field names in here. So the JSON type is a self-contained format, meaning every row is converted to a self-contained JSON type. And since these field names are all unique, we don't get any compression here. So now that doesn't say that this is the only way to compress data. There are some other mechanisms, but which don't have such a big effect. And here it's kind of what we see is also atypical data where it's very small. So on average, what you see, what I would say like for a typical use case, you should see the JSON type to be about, let's say 70 to 80% of the size that the text would take. So it is smaller, but it is not half the size. And if you have tiny documents, it is not smaller at all. It might actually be slightly bigger. Good. So now I've covered this the size aspect. Now let's look in performance. So now you see here there is a, now there should be a type somewhere here. This is our Now let's just run this. It's not ordered well. And now you should see there's like some 163. That's the maximum type. So we're looking across all these 70,000 JSON documents. We search for the type field and we look for the largest one, which is 163. And this took about 0. Let's run it again. 0.2 seconds. So data is not very large, and this is on my laptop with Docker, so these numbers probably have to be taken with a little caution. But let's run this over the text and see if it takes longer, and it actually does. It's 0.8 seconds. So again, this is what I would expect is about the JSON data type to be like on average maybe 3x faster for full table scan situations like this. And the reason is that for the text JSON, we have to scan through the data until we find this value. Whereas for the binary data type, this first data structure, the header that has these, replaces this with an ID, and then I have direct offsets that I can jump to the data. So I can basically skip all the other field names. Good. So the message here is JSON data type gets you a bit of space savings and significant performance improvements. Obviously, performance for full table scans, the moment you use an index to retrieve a document or a materialized view, then you would avoid full table scans, and the performance between text and JSON would not be so big. Good. Now let's look at something else. And this is a trailing function. So here we are extracting this value, and you have the ability to put another function on the end. This is also a 19C feature. This is not really new in 20C, but let's just run this and see what the data type for our type is. And we see type is a number, and the same is for the test JSON. So it says all my instances, these are numbers, and number is something that really exists in the JSON domain. But now let's run the same here if on a different field. So this is our a column called seed time. And in the relational schema, this is a date data type. So I've taken a date value and I've converted it to JSON binary and JSON text here. And let's ask what the data type is. Now it's interesting. Now for the JSON binary data type, it actually tells us this is a date. So the information that this value is actually a date is being preserved in the JSON. If we, on the other hand, look at the text, it tells us it's a string. And the reason is as follows. JSON does not have a data type for date or timestamp. So what it has to do, it has to put this into a string. We use the ISO 86 date format, 8601 date format. So at least we're putting it in a well understood format. But at the end, since JSON text does not have these data types, we have to use a string. So this is not an Oracle limitation. This is a general JSON limitation that there is no data type. But the moment we go to our to the binary data type, we preserve this information up to the point where you serialize it. So if you would ship such binary type to Java or another programming language, you would see it really as a date. So there is no lossy conversion happening. Similarly, why did I put this in? Signature. This is a binary. So this is a raw field. So signature is a raw. And we do have null values and some binary values. So basically the moment you have a value, it's saying, oh, a raw, that's a binary. And guess what happens if I run this on the text? There is no raw or binary data type in JSON. So again, this is a string. So what's the message? The message is you have richer data types, which also means if you round trip data through JSON data type, you're not losing any type information. Good. And while we are on the topic of these trailing functions, there are some new trailing functions. I think they are new in 20C or 21C, but they are probably also being backported. So this is another example here. I use the with clause here. I select a JSON array, which has these 6 values. And then I select these 6 values. So I'm selecting each of these in like the path language selects these values, and then I invoke this max number. And this should give us the largest number in the array, or I could use the sum function to sum it up, or the average function to calculate an average. So why is
very cool? That is great.
Yeah, so the benefit of this is if you have multiple values in your JSON, for example, a JSON array, you don't need to run JSON table to convert that into the relational model and then put a sum or an average on top. Instead, you can use these functions directly in the JSON path language. So that may save a bit of writing here. Yes, there's min string and max string and similar thing. There's also, I think there are also some number only function. Let's see how this works. So this, I'm trying this out. This may not go well. Let's see if this works. Number only. No, this would work with JSON query with the array. Okay, forget what I just said. We can, if we have time, we can try this out later, what I meant with number only. Basically, there are some trailing functions where you can say, I only want to get, for example, the numbers or the strings. So you have something like this, which is not a number, then it would be removed from the result if you write number, the number only function. And the reason it doesn't work here is because we are selecting multiple values and we probably need JSON query with the array wrapper. Good.
Question for you?
Yes.
This is from Stu Ashton, quote, constructor JSON can be used with a special syntax as an alternative to using JSON object and JSON array when generating data of data type JSON. His question. So JSON squiggle, open close squiggle generates the data type JSON. Is this new data type backported to 19C?
No, the new data type is not backported to 19C.
Also, Stu tried out the JSON squiggle syntax. And
you're right.
Didn't find it working on Cloud ATP or Live SQL 19.8. So later patched than that.
Yeah. Yeah. That is basically this JSON curly brackets. That's just short for JSON object. It's actually just a syntactic sugar. Good. Let's run this query here. So now we are going back to our text table, and we are selecting this type. What is the type of an object? I think type 4 means views. So how many views do I have? 7,626. And here, this is this dot notation, the simplified syntax, and that returns a varchar to 4,000 value. You could probably put a number trailing function on here and it should work. Always dangerous, these life changes, but in this case it worked. So let's run this with JSON. So the only difference in this query is that this is test JSON. And what's happening? We get an error. So this is like my big font size is being ignored here, but you see, or something invalid comparison invoking JSON type value. Okay, what's wrong here? So because our data here uses JSON type, this path expression now also returns a JSON type. And a JSON type could be a number, a string, but also an object or an array. This is why direct comparison is not allowed. You have to put a trailing function on here. This is something we probably should have emphasized a bit earlier, even on 19C, to say, well, please put such a conversion function at the end, for example, string, so that it clears in what domain you are performing this comparison. So now with the JSON type, this is no longer mandatory, but optional. Not optional, but mandatory. You must do this, otherwise you can't compare it. So JSON type is not directly comparable, which also means you cannot put an expression like this to create an index, because if you insert values into an index, you use them, or you use comparisons on them, range comparisons, equivalent comparisons. So here you tell, if you would create an index, what kind of, how you want this data to be treated. Good. Another change, this is was new in 20, and I think I already spoke about it, but I repeat it again. It's the question about what is actually JSON. And there was a change in the RFC. So Oracle didn't change it, but people behind JSON said, well, actually JSON is not only an object or an array, we also now consider some scalar values to be JSON. So for this, let's create this table. We're doing a lot of stuff here. I apologize. Let's just drop this table for a second. Okay, so I create this table and then I insert some values here. It's the so everything is in a single quote. That is just to make it because it's a SQL literal. But if you look at the difference between dog and cat, then cat has these additional double quotes here, and this will make a difference. So now let's see at everything. What is JSON? Now it says JSON, all these values are JSON, but not the dog. The dog is not JSON. And if I use is not JSON, I will get the dog back. So the way you can, I think the way this makes most sense is if you look at the JSON serialize function. So JSON serialize takes a JSON and creates a JSON string. And each output of JSON serialize basically passes the isJSON test. So for example, a number fits is a JSON. It's a possible JSON value. It doesn't have to be an integer. It can also be like a float or a double. True and null are JSON. And so is cat, because cat is a string, and it's a string because you have these double quotes around it. And you could also have, for example, true with double quotes. Then it would be the string true versus the true above, which is the Boolean true.
Any question for you, Beta?
Yeah.
Wasn't it supposed to automatically apply null on error for the rows where the value is not a number, and so just ignore them, considering the comparison with 4 as false? I think we have to go back a little bit, yeah.
This is not really an error case. So this expression here from a SQL point of view, so let's take a look at it from a SQL point of view. This is an expression that returns you a JSON type. I could, instead of this simplified syntax, I could also have written foo, like a PL SQL function that returns a JSON type. And then the error occurs here. So this null on error or error on error is basically defining how to handle an error while you do your JSON path processing, or it's error handling for a JSON operation. But the JSON operation here itself, it succeeded. It extracted this value, it returned a JSON type, but then you did something with a JSON type that is not valid. So that's always a challenge that we are working within two different language domains. One is SQL, and the other one is the SQL path language. And I will give another explanation for this in a second at the bottom. I hope this answer made sense here.
Thanks, Betty. I think it makes sense. Yep.
Good. So now this is obviously a big change here. Like we say, well, we used to only say object and arrays are JSON. Everything else would get rejected. And now you tell me, well, that's no longer true. So how can I keep my old behavior? So first of all, you have to set compatibility to 20 to get this new behavior. So just upgrading to 21 will not give you this. For on-premise customers, I think if you're in the cloud, most likely the compatibility is already set to 20. So you will get this behavior from the beginning. But what you can do is you can say disallow scalars, and you get back the old RFC behavior. So the old RFC was only object and arrays are JSON. The new is also any JSON, any serialized JSON value. So what is this with minus here? This is everything that's new. Like what are the things that are considered now as JSON? And those are these numeric values. I don't know why there is this black bar here on the screen. It didn't used to be there. The null value and, for example, cat and the Boolean value. I actually think that this makes it easier because now the internal data model of JSON is also the external data model. We always used to have exactly the same values as values that you could select, for example, with a path language, but then you kind of had to wrap them in an array in order to return it. And that's no longer the case. Good. So let's get to the next feature. A lot to cover here. Dataguide. So you all know the Dataguide, which gives you a structural summary of the data. So I should have opened my JSON lint here. Just pulling up a quick web browser. So there is no pretty printing yet in the SQL developer. So I use this tool called JSON lint. I'm not affiliated with it, but it does me some pretty printing. So what I get here is a summary of all the fields inside. So if, for example, I see there is something like a name, it's a string, and it would fit into 128. Or I see there is a C time, and it actually now tells me this is a date. Very good. And there is another option here. This is the statistics. So the Dataguide, I think, was first introduced in 12.2 and then got a lot of new capabilities in 19. And now with 21, we can also gather some statistics. So let's run this. And copy it into the pretty printer. And what I get now, in addition to, let's say this is the name. So in addition, what in this, without the statistics, I would get like, this is a name. It's a data type string. It fits into 128. But now I also get like the min max values, get the number of nulls, and I get the frequency, like how often is this field occurring under its parent node, for example. It's in this data set, the frequency is all 100 because I created it from relational data. There is no schema flexibility in here. But imagine you had some JSON, which is quite common, where some fields are optional. Then let's say you have in 1% of the data, there is a middle name, or maybe probably more than 1%. Let's say in 50% of your customer data set, people not only have a first and last name, but also a middle name. Then the old data guide would just tell you there's first name, last name, middle name. But with these statistics, it could actually tell you, well, middle name is not such a common field here. Good. This may be quite interesting. So another thing while we're at it, and for this one, I'm not sure if this is actually 20 or 19. I haven't looked it up, but I think it's worthwhile to mention it. So I'm creating a new table here. I call it GJ for GeoJSON. Okay, I need to drop it. GeoJSON. I did not put all my drops at the bottom to make it rerunnable, so I created, and now I insert some JSON. It's very small. It has some field names here. Nothing is really looking out of the ordinary. And I run this now, the JSON data guide. Let's take a look at it. And there is not much surprises here. So it tells me, well, I put the side by side here also. Tells me, well, beta, you're looking at an object, and your object has a field called type, and type is a string. And then there is a field that's called geometry. That's also an object. And in that object, you have fields which are called type. It's this one, and coordinates, which is an array. So this is the standard data type. But there is another, there's a caveat to this, that this actually follows the GeoJSON format. So there is a standard for spatial information called GeoJSON. And what I can do optionally is to say, Dataguide, please make sure if there is a GeoJSON inside there that you detect it. So there is nothing from a JSON type point of view or syntax that makes it a GeoJSON. It's really the shape and the names of the field names. So now it's saying, well, geometry here. So this guy, this is actually a GeoJSON. Okay, so now I know I have some spatial data. And if I now use that data guide and this little PL SQL block to create a view. So this is the DBMS JSON create view. I create a view over that table. And now if I describe it, I see that this geometry is not, or I don't have columns for these individual field names. Instead, I see that geometry is an SDO geometry, which is our spatial type. So if I select from it, I should be seeing, well, it's not giving me, I can't look inside, but now I could do spatial operations on top of this. Good, that's what's new in Dataguide land. Let's look at JSON transform. So again, this is our example that I just put here, with spatial data. And we actually had an AskTom a while back on JSON transform when it was about what's new in 20C, when nobody knew that 20C would never really see the world. So this is why I don't go into depth into JSON transform here. Just want to show there is a new operator to update your data. So I use it here in the SQL update clause. And then I can have a list of modifying operations. So it's not only a single update I'm doing, I can do multiple, and they are actually executed in order. So what I do here is I'm setting a field type to ABC, and we have a field called type here. So the feature, the value is currently featured. So I want to change that to ABC. Makes a lot of sense, this example. Then I want to do an operation on the array, and I don't want to replace the array. I just want to append to it. I don't know how much is in that array. I just want to append a value, and that value is XYZ into this coordinates array. So you see I'm going to geometry and then to coordinates, that's an array. And then I'm renaming the field that's called geometry to geo. So let's run this and select the value. And I probably totally destroyed this GeoJSON. It's like pretty useless data at this point, but you see that the updates have been done. So you see ABC, you see I appended to the array and I renamed it. So this is one use case of JSON transform, to use it in actually updating your data on disk. Another interesting use case is to use it in the select list, where you say, well, before I ship my JSON to the client, I'm doing some updates or some modifying operations. So in this example, I am adding a timestamp to this data to add information when it was loaded. So now a client could see, oh, this record is from that timestamp. Or for example, if the JSON data had private information like a credit card, I could just use a remove operation and remove that part. Good. Not much more on JSON transform. You can read up more in the doc or watch the old video. Good. Now we're looking at something else. I call that value cardinality. That is not new yet. I just want to introduce this concept. So let's say I'm storing some customer data, and as sample data, I use my favorite cartoon, Tintin. And let's say a customer lives somewhere, a customer has an address, and I've simplified address here just to the city to make it readable. Obviously, a real record would be much bigger. But I say, well, Tintin, he lives in, or Tintin, he lives in Brussels, and his best friend, Grumpy Captain Haddock, he lives in Marlingspike Hall. Good. So this is my big customer database. And now I could use, for example, I want to find who's all living in Brussels. So I use this simple notation, address city Brussels. And it's telling me invalid comparison. Just to repeat it, I have to put a trailing function on top. So I put the string trailing function on top with Brussels, and I see that Tintin, he lives in Brussels. Now our friend Haddock, he's pretty rich. He's getting older. He wants to live closer to his friend Tintin. So he buys an apartment, a second address in Brussels. And now using like a pretty verbose JSON transform here. So you see that right now the address is an object, and I want to add the second address. So right now I haven't added functionality yet to convert an object into an array of the same objects. Now what I do here, I first create another key address, which is a JSON array. Then I append the current address to this array. I add the second address into this array, also in Brussels. Then I remove the old address and I rename the new address to the old address. So it's a bit hacky, and I only do this for haddock. It's a bit hacky. We probably should add another option here where we can say if you want to convert an object to an array of the object, there should be an operation for this. That thing is not there yet, so I did this hacky way. So now if we serialize this thing here, what we see here, that haddock address, he has now twos. One is in Marlingspike Hall, that's his castle, and the other one is in Brussels next to his friend. That was easy, but now let's use the same query expression here where the city string is in Brussels. And what we see back is 1010, but we don't see Captain Haddock, who just also maybe not moved, but has an address in Brussels. And the reason again is that this equality here happens in the SQL land. And what we are selecting is not Brussels, but these two addresses. So if we look at address.city, the value here is the array of these two addresses. So that's not new. That has been there for a long time. So we told people don't do the comparison in SQL, instead use it directly in the JSON path language. So this is why instead of using a simple SQL comparison, we use this JSON exists operator that performs the equality check on each value of the address. So here in this path expression, we go to the address, then we evaluate this filter introduced by the question mark. What's the filter? Well, the city should be Brussels. And this statement here has the implied semantics that if address is an array, we are evaluating this filter check on each item of the array. Good. So now this works. The JSON exists expression is getting evaluated correctly. Again, nothing new 21C. This is just a very long introduction. So now let's say in my customer database that contains 2 customers, I'm adding many, many more. And I'm traveling a lot, so I want to find who are my friends in this city where I'm currently at. Well, Corona times nobody travels, so not a good example. But I want to put an index on the city. So what I do is I just use JSON value, address city, and I want to create an index, which is called C index, and I get back an error. And the error I'm getting, and I get back the error because I use error on error. That's always good for the index creation, because then I know if something goes wrong and it does not index a null value. And the error I'm getting is saying, well, JSON value evaluated to multiple values. And that's actually true because our friend Captain Haddock has 2 addresses, but a functional index to be used. This is basically a functional index because I create an index on this function. That function is meant to return 1 value. So this is an error. And for this, with 21C, we've added a new multi-value functional index. So this is really new and very, very exciting. This was a gap in our functionality. We could work with this with materialized view or the JSON search index. The JSON search index never had this problem, so it would index these array values, but functional indexes up until now could not index multiple values for the same column. And this is this new syntax here, create multi-value index. And then I say on customers, and the expression is just go to the city and index it as a string. So let's run this guy here. Multi-value index created, and now we run the same query. We get back Captain Haddock, and let's look at the explained plan. And you see here what we did was a scan of this multi-value index. I hope you can see this. This part at the bottom ignores my font settings, so it's a lot smaller. But in the explained plan, you basically see that it did a index scan for this. So this is very, very exciting. The that we are able to have a multi-value index, because now we can really index into array values. So now you may say, well, this is the simplified syntax, whereas on the other indexes, we could also use the full like JSON value, these operators. So what is the simplified index for? And it's basically short for a JSON table expression. So I could also, and this is not documented yet, it probably will be documented in a later patch set, but from conceptually, what we do if we create this index is we run something similar to a JSON table that iterates over the array and extract this value. So for the single, or for these, for our data set here, let's just run this again. So our data consists of 2 rows, but the index will actually be populated with 3 entries, 2 for Brussels and 1 for Marlingspike Hall. Good.